This video clip is from mathsdvds.co.uk and mathstutor.biz, and we're looking at a GCSE Foundation practice paper. At least we're looking at one question from this practice paper. We're going to be looking at question number 17. Question number 17 here. Work through it in detail, giving you all the answers and how to do it, along with the marking scheme for this particular question. But if you want to see the whole paper, you can obtain your own copy along with the DVD that will go through all the questions in detail. Visit mathsdvds.co.uk or mathstutor.biz, where you can buy your own copy. Let's have a look at this question number 17. GCSE Foundation practice paper from mathstutor.biz and mathsdvds.co.uk, paper 1A, question 17. In the diagram, I don't know if there's more written on the exam paper. Sometimes I put more on the question paper than I actually do on my working out sheet, but that's the important thing, isn't it? Diagram not accurately drawn. So that's another phrase meaning the same thing. Diagram not to scale, diagram not accurately drawn. So as I said earlier, you must assume that's the case whether it says it or not. The only time it isn't the case is if the question says quite categorically and quite clearly this diagram is to scale. If it says that, then fine. Means you can't measure things. Okay. So we're told that QR is parallel to ST, so let's put the symbols on there to show that they're parallel, because we're told it. We're told that PQ equals QS equals 8, so that's 8 centimetres there, and that's 8 centimetres there. And QR is 12 centimetres. Why are the triangles PQR and PST similar? I've worded it a different way on that paper, but it means the same thing. Why are those two triangles similar? Now you don't have to, but it's a good idea to actually draw those two triangles as separate triangles. Sometimes it's easier to get your head around what they're on about. So that's PQR and PST. So let's consider them as two separate triangles. What does this word similar mean? Well, non-mathematically means look the same, but mathematically is a bit more precise. And to be similar, the angles must be the same. That must be the same as that. That must be the same as that. That must be the same as that. And the sides must be in ratio. Now it's even one step more than that. If it's triangles you're talking about, to be similar, you have to either prove the angles are the same or the sides are in ratio, because you can't have one without the other. Whereas if it was two shapes that weren't triangles, say they were four-sided shapes, quadrilaterals, to prove they're similar you'd have to prove both angles are the same and sides are in ratio. That's quite a lot of mathematics I've explained there. Could be worth listening to again to understand what is meant by the word similar in mathematics. For two shapes to be similar, the angles must be the same and the sides must be in ratio. When you're doing triangles, you only have to have one of those things and the other one must be true as well. So, why are these two triangles similar? I need to prove that that angle equals that angle equals that angle, and this angle equals this angle. And we're back to parallel lines. Looking at this diagram, this angle equals this angle. Looking at this diagram, this angle equals this angle, because they're corresponding. So let's write that down. Shorthand for angle is to put that above the three letters. PQR is talking about that triangle there. Sorry. PQ QR is talking about that angle there. PST is talking about that angle there, or in this diagram, that angle there, that angle there. They're equal because corresponding. You have to have those two statements, what you're talking about and why. Similarly, this angle here equals this angle here, because they're corresponding. PRQ equals PTS Now the last angle, which is the same in both of them, there's two ways you could go about this. You could say the three angles of a triangle add up 180 degrees, so if those are the same, then the third one must be the same. Or, it's called a common angle. It is the same angle in both diagrams. QPR is the same as P. Say that again. QPR is the same as SPT. QPR is the same as SPT. It's called a common angle. So as I did say, you could do that third angle by some statement about the angles of a triangle add up to 180 degrees, so the third angle must be the same. These sort of questions candidates do tend to find difficult to think what to write down. Sometimes they know what it is and can't think what to write down. The examiner's not looking for full-scale sentences, looking for key words. So if the key words are there, you're likely to get the marks. So let's see what we're going to get for that. Question 17. Well, it's worth 2 marks. Somehow or other 2 marks. So, well, I'll be honest with you, your guess is as good as mine with where the 2 marks are, but that's it. A bit mean, I think, on the mark front there. And here we have the same diagram. I've done it again just to make it so I'm not getting in too much of a cramped state. Calculate the length of ST. Now, as I said, looking at the 2 separate triangles, because we've now proved they're similar, then the sides are in ratio. So the ratio of that to that is the same as the ratio of that to that is the same as the ratio of that to that. So let's look at these 2 sides here. This one is that 8 there. This one is the whole of that, which is that 16. The 2 separate triangles drawn make it clearer. 8 to 16 is the ratio between the 2 triangles. This is 12. So what is ST? Well, we call this an enlargement. It's an enlargement of scale factor +2. Because that side has been doubled. Therefore that side must be doubled. So ST must be double 12. Now that, if you understand the mathematics, is actually an easy question, but it's understanding the mathematics that makes it easy. You need to look at the 2 separate triangles and appreciate it's an enlargement of scale factor 2. Then, right, the 2 marks, not for the units, one for the method and another one for the accuracy of 24.